Hi students, today we are going to discuss about potentiometer from the chapter current electricity. So potentiometer is a device which is used to measure the potential difference between 2 points in a circuit. Okay, that is the use of potentiometer. So potentiometer is a device which is used to measure the potential difference between 2 points in a circuit. Okay, so this potentiometer consists of a 1 meter long wire. Potentiometer consists of 1 meter long wire. Okay, it have uniform area cross section. Okay, is fixed on a wooden board. It fixed on a wooden board in a zigzag manner. So it is a diagram for potentiometer. So this is a wire. It's connected on a wooden board in a zigzag manner. It have a length of 1 meter and it have uniform area cross section. Okay, is fixed on a wooden board in a zigzag manner. Okay, and it have two circuits are there. They have two circuits. So one is primary and another one is secondary. So first we are going to discuss about the principle of a potentiometer. What is the working principle of a potentiometer? Okay, again I will repeat. So potentiometer is a device which is used to measure the potential difference between 2 points in a circuit. Okay, and it consists of a long wire having uniform area cross section, is fixed on a wooden board. That wire have a length of 1 meter, is placed on a wooden board in a zigzag manner. That is the concession part of potentiometer. Now we are going to discuss about the principle of potentiometer. So this is the diagram of potentiometer, and this is a long wire having length 1 meter and a uniform area cross section, and it have two part. One is primary part and another one is secondary part. So this is the primary part. Primary part consists of a cell, a key, an ammeter and a rheostat. The function of primary circuit is to provide constant current through the wire of a potentiometer. The function of primary part is, the primary circuit is to provide a constant current through the wire of potentiometer. Okay, so the principle of potentiometer. So for here we are considering secondary, we connected to a voltmeter and connected to jockey. Okay, so we measure the potential across 50 centimeter, 100 centimeter, 20 centimeter. Okay, so the voltmeter show a reading. Okay, so the potential drop across a point between 2 points in a circuit, the potential difference between 2 points in a circuit or in the wire is directly proportional to the length of the wire, under a constant current is passed through it. That is the principle of potentiometer. That means the voltage drop between 2 points in a potentiometer wire is directly proportional to the length of the wire. That is the principle of potentiometer, provided a constant current is passed through the potentiometer wire. Suppose V is the potential drop across 2 points in a circuit and L is the length, then we can write V is proportional to L. V is proportional to L. Here L is the length. L is the length and V is the potential between 2 points. V is the potential between 2 points and L is the length between those 2 points. So from this we can write V is equal to KL. V is equal to KL. K is a constant, and from this we can write V by L is equal to K. So this is called potential gradient. Potential gradient V by L is equal to constant K, that is called potential gradient. So potential gradient is the potential per unit length. Potential per unit length. By looking this, we can say the sensitivity of a potentiometer. If potential gradient is less, potential gradient is less, we can say that potentiometer is more sensitive. If this value, K value is less, we can say potentiometer is more sensitive. Okay, that's about the principle of potentiometer. So again repeat, what is the principle of potentiometer? The potential drop across any portion of a wire is directly proportional to the length of the wire, provided a constant current is passed through it. That is the principle of potentiometer, or otherwise V by L is a constant. The potential drop across unit length is a constant, that is called potential gradient is constant. Okay, and if potential gradient is less, we can say that potentiometer is highly sensitive. Now we are going to discuss about the application of potentiometer. Now we are going to discuss about application of potentiometer. There are mainly two applications. One is to compare the EMF of two primary cells. That is one of the use of potentiometer, to compare the EMF of two primary cells. And next application is, second application is, it is used for measuring internal resistance of a cell. It is used to measure internal resistance of a cell. The first we are going to discuss, the first application, the compare the EMF of two primary cells. To compare the EMF of two primary cells. So this is a circuit diagram of comparing the EMF of two cells. So this is the wire of potentiometer PQ. One end is P, other end is Q. Okay, and is a primary circuit, and the positive of the driver cell is connected to the P, and a key and an ammeter and a rheostat. The function of the primary circuit to provide a constant current by adjusting the rheostat. And the secondary circuit consists of two cells having EMF E1 and E2. So we need to compare these EMF of these two cells. Before doing this experiment, for comparing EMF, you need to make sure the driver cell EMF should be greater than E1 and E2. Then only we get the correct balance length. That is, E should be greater than E1 and E2. Then only we get the balance length. Okay, before doing the experiment, you have to make sure the driver cell, that is E, that voltage must be greater than E1 and E2. Okay, so now we can discuss how we can comparing the EMF of two cells. We know the principle of potentiometer. The potential drop across any portion of a wire is directly proportional to the length of the wire. By using this principle, we are comparing the EMF of two cells. So first we have to find out the balancing length for E1. Before doing, we need to adjust the rheostat, put the key here and adjust the rheostat, and a constant current is passed through it. First we have to find out balancing length for E1. So we connect 1 and 2. We connect 1 and 2. The terminal 1 and terminal 2. Terminal 2 is connected to galvanometer and a jockey. Then we move the jockey from the positive end to the negative end. We move the jockey from positive end to the negative end. The first we are finding the balancing length for E1. We connect 1 and 2. Okay, and the terminal 2 is connected to galvanometer through a jockey. Okay, so then we move the jockey from the positive end of the wire to the negative end. That means from P to Q, a point J is reached. A point J is reached. That time the galvanometer show zero deflection. Galvanometer show zero deflection. That means the potential across E1 is balanced in this length. We consider this length is L1. Okay, so L1 is the balancing length for E1. So we move the jockey from the P to Q, a particular point J is reached, the galvanometer deflection is 0. That means the voltage across E1 is balanced by the length of this portion, Pj. So we can write, according to principle of potentiometer, we can write E1 is proportional to L1. E1 is proportional to L1. Here L1 is the balance length for E2. Next, we are going to find balance length for E2. So we connect terminal 2 and 3. Connect terminal 2 and 3. Then we move the jockey from P to a point, okay, P to Q, a point J dash is reached. A point J dash is reached, and the galvanometer shows 0 deflection. That means the potential across E2 is balanced by the length. That means the potential by the length Pj dash. So we consider that is L2. L2 is the balancing length correspond to E2. So according to principle of potentiometer, we can write E2 is proportional to L2. E2 is proportional to L2. So from this, we are dividing equation 1 by 2. Then we get E1 by E2 is equal to L1 by L2. So this is a way of comparing EMF of two cells. First we find the balance length for E1, that we got it is L1 according to principle of potentiometer. Then we find balance length for E2, that is L2. Then we divide 1 and 2, so we get E1 by E2 is equal to L1 by E2. So we can compare the EMF of two cells. Okay, and you need to make sure one thing. If you are comparing EMF of two cells, the driver cell voltage must be greater than the E1 and E2. Okay, that's about the comparison of EMF of cell by using potentiometer. Now we are going to discuss about how we can measure the internal resistance by using potentiometer. So we all know that about internal resistance. Internal resistance is the resistance offered by the cell when a current is passed through it. Okay, internal resistance is the resistance offered by a cell when a current is passed through the electrolyte. And also we know the factors affecting the internal resistance. One is the nature of electrolyte, the separation between the electrode, temperature. These are the factors affecting internal resistance of a cell. So we are going to discuss how we can measure the internal resistance of a cell by using a potentiometer. So this is the circuit diagram for measuring the internal resistance of a cell, and it have a cell E1. Okay, we have a cell E1, and we are measuring the internal resistance of this cell E1 by using the potentiometer. So this is a primary circuit and this is a secondary circuit. In the secondary circuit, we have connected the cell E1 through a resistance box RB, and a key is here K1. The first is switch on key K and adjust the rheostat as a constant current is passed through it. Constant current is passed through it. Okay, so we are explaining this in 2 steps. Okay, first you need to balance the cell E1. First you need to balance the cell E1. Okay, so here the key K1 is open. K1 is open. So this RB is not in the circuit. Resistance box is not in the circuit. Then we move the key from the end P to Q. We move the key from move the jockey from. We move the jockey from the P to Q. A point J is reached. So the galvanometer show a deflection. That means the cell E1 is balanced by a length. We consider that length is L1. So we can write E1 is proportional to L1. E1 is proportional to L1. First K1 is open. We are balancing the cell E1 by moving the jockey from one end to the other end. A point J is reached. The galvanometer show a deflection. So the cell E1 is balanced. So we can say E1, according to the principle of potentiometer, we can write E1 is proportional to L1, or otherwise we can write E1 is equal to K L1. That is equation number 1. Okay. Now the key K1 is closed. K1 is closed. So the circuit, the resistance RB is in the circuit. Okay, the resistance RB in the circuit, so current is flow through it. Current is flow through it. So the potential across E1 will be reduced, as that is now it will be the potential terminal potential. Now it becomes the terminal potential because the K1 is closed, the current is passed to the cell. So the potential will be reduced. Now it will be the terminal potential because due to the internal resistance. So we consider V is the terminal potential. Now we are going to balance the terminal potential. So we move the jockey from the end P to a point, point J dash. So the galvanometer shows zero deflection. Okay, that means the terminal potential is balanced. Okay, we move the jockey from the end P to the other end of Q, then a particular point J dash is reached, the galvanometer shows zero deflection. That means the terminal potential is balanced. Suppose we consider L2 is a balanced length for the terminal potential, so we can write V is proportional to L2. V is proportional to L2. Okay, we know that before we prove that E1 is proportional to L1, that is equation number 1. So divide these two equations, equation 1 and equation 2, we get E1 by V is equal to L1 by L2. E1 by V is equal to L1 by L2, that is equation number 3. Okay, so V is a terminal potential. Okay, but when a switch is closed, a current is passed through it. So we can write the potential in this part is given by E is equal to I into R plus R. E is equal to I into R plus R. And we know that the potential across the resistance is equal to the terminal potential. The potential across the resistance is equal to the terminal potential according to Ohm's law when we are connecting the key K1. So we can write V is equal to I into R. V is equal to I into R. So dividing these two, we get E by V is equal to R plus R by R. From this we can write 1 plus R by R. Isn't it? E by V is equal to R plus R by R is equal to 1 plus R by R. Separately divide, R and R will be cancelled, so we get 1 plus R by R. That is equation number 3. But we know that E1 by V is equal to L1 by L2. That you need to remember. Okay, this is E1 actually. E1 is equal to I1 R1 plus R and V is equal to I into R. So we get E1 by V is equal to 1 plus R1 by R. Then by rearranging this, we can write R plus R is equal to E1 by V minus 1. R1 by R equal to E1 by V minus 1. But we know from equation number 2 what is E1 by V. E1 by V is equal to L1 by L2. So this equation becomes R by R is equal to L1 by L2 minus 1. L1 by L2 minus 1. And from this we can measure the internal resistance R. R is internal resistance, R is equal to capital R into L1 by L2 minus 1. So this is the equation of finding the internal resistance of a cell. Here L1 is the balancing length. L1 is the balancing length without introducing the resistance box when K1 is closed. Okay, so L1 is a balancing length for E1 and L2 is a balancing length when K1 is closed. Therefore, the terminal potential. Okay, so this is the equation for finding the internal resistance of a cell. R is equal to R into L1 by L2 minus 1. L1 is a balancing length when K1 is open and L2 is a balancing length when K1 is closed. And capital R is the external resistance and R is the internal resistance. So this is the expression. This is the expression for finding the internal resistance of a primary cell. you.